solve this LeetCode problem called pour water. And this problem is a little bit unusual because it it is kind of a simulation problem. You cannot use two-pointer as far as I have observed. So in this problem, we're given an elevation map representing the integer array heights. So we're given a height, and there is a integer volume that gives you an integer amount of waterfall at index k, and each of the heights are 1 unit apart. Just for example, this is the given input 211, 2122. So this is 2 units height, so 1 unit height, then 1 unit height, 2 unit height, 1 unit height, and the last two are 2 and 2. So 5 and 6. So there's a total 7 values here, but you can assume that at the very beginning and end there's a very high and tall infinitely tall walls to very ends. So here the assumption is that we dropped some water at the integer k equals 3, and we have a full volume of water, and you have to return the array after the water actually gets splashed out to the left and right. So the problem is definition says eventually fall, which means basically you have to assume that once you have dumped the water on this index height, it has to move left or right, and it depends on your strategy how you're gonna find out where they end up. So just for this example, let's draw out the structure. So there's infinite height, infinite wall, and you have this is the wall right on the left and right, and you have 2 units. You have 1 unit, 1 unit, 2 unit, then 1 unit, then 2 units, and there's 2 units. 0, 1, 2, 3, 4, 5, 6, right? And here in this this particular block, we're going to get water. Let's use light blue color for that. So you have 40 units of water. 1, 2, 3, 4. Now where do they go? So the first unit of water, you can actually go either left. This one, you can either go left or right. And to go to the left, you can see this water can actually occupy this space, but there's a one on the left which is also available. So it will not stay there, so rather it will actually move to this side. And the logic is you can ignore, so your v is equals 4, right? So 4 unit of water and k equals 3, and 3 is this position. We start pouring all the water, and you can actually ignore these 3s, and you can only start with the first one. First one here, and you can see once the water is dropped, you can check on the left side for the depth or height, and if it is lower than the current height of this block, your current height is 2, right? And if this left one is 1, so it can actually just pour over here, and then this is 1 again, right? And it can actually keep sliding to the left, so it will go here, and that is one way of solving this problem. And basically, if you have this one setup, you can say that, okay, your current volume, you're currently settled at 3, right? Index 3, but in the left one, and the height at 3 is 2. But if you move to the left, then you will see that this particular spot has a height of 1. This height, let me use a different color. So this particular one has a different color. So this is 2 units. This is then 1 unit, right? And this is also 1 unit. And first of all, this one is 1 unit, so yeah, and this one is 2 units, so it can actually go here. Then you can say the settle, you can actually settle down at index 2. So as long as this current value height is less than your previous value, and then at this point when you just go to the next one, the height is actually still the same, so it doesn't have to move to the left. And if that is and after that point, if you go to this index 0, if you try to just find out, hey, this is second height, so it's too high, right? It can actually move to this one. So you can say the water will eventually drop to this point, and we can get rid of the water here. So this is, now we have a remaining 3 units of 3 volumes of water, right? And at this point we can restart the process. At every single time we have another unit of water, let's say another unit of water here, and you can go to the left and to the right, but for this case we're gonna keep going to the left first until all the voids are filled, right? And there's a little mistake. I need to make them the height at the same, so 2 units, right? And this volume of water, this second unit, this can actually, if you look at the height, this height is 2, this height is 2, and this height is again now 2, right? This one is also 2 because there's some water, so it's gonna stay here, so it can go to the index 1. And when it goes to the index 1, this index 1 is less than its current height, h equals 2, and at this point it's going to take over this spot, and now this height is going to be 2. So your array was initially going to look like 2 1 1 2 1 2 2, right? 2 1 1, and because we added the water here, so this becomes 2, and now this will become 2. Now your volume is going to be 2 because you have 2 more units of water. So to start over again, so you actually have another unit of water. This is third unit of water, and if you see, this is of height of 2 in the current position, this is 2, and you have water here. Let's use a different color. So these are the bricks, right? Sorry, these are the bricks, and these are water. Oh, I'm not really that great at drawing. I have to use this one. So this is water, right? But with the water, these are all height 2 now. This is height 2, this is height 2. So if you keep going to the left, you will still have height 2, right? So this block was height 2. And that's why this water cannot move to the left anymore, because there's a long high wall. So you still haven't found a lower place that can take this water, so you can actually go to the right. So in the right, you see this height is just 1. I'm gonna erase this piece. This block has a height of 1, and this current height is block of 2. This one is 2, but this one is only 1, so you can actually find a home here. You have the settle down point right here, so you don't have to do anything. And finally, you have 1 unit of water left. At this 1 unit of water, we have to just redo this. So you have now at this stage, these are all water, and so this is your brick block, right? I'm just drawing them out. These are brick, these are all brick, right? It's all brick, and you have water here in this block, You have water in this block and you have water in this block. The last unit of water, as soon as you dump it into k equals 3, the third index equals 3. This is the water, right? Water. And this water, you can actually keep looking to the left. You have no other place which is a height less than 2, which is this side at index 3. And you have no other place to the right as well. So that on the end, so you just do not move anywhere. It just is at 3. So this is the final result you have to return for this example. So let's go to the code and how we're gonna do it. The runtime complexity for this algorithm is going to be order of n times v, where n is the length of this array. Here it is 7, and v is this value, which is initially 4, and this is the time complexity. And for the space complexity, it's going to be order of 1 because we don't need any other extra space. But the logic is very interesting. So we can say our n is length, and we can start off with v as a variable v, and we're going to iterate over all the unit of volume. So v less than volume v plus plus, and we have to define where we are, what is the current height. Current age is going to be height of k, where we're starting, right? So at the kth index, which is 3, this is the current height, right? This is going to be true, and every single time we're going to find out, settle at index, where we're going to settle this water droplet at. And this is going to be initially it's going to be just k, and now we know the water is here at the kth position, at the current height is 2. Now we need to go to the left for the first water droplet. For integer position equals, we have to start at the left side of current k position, and we can actually keep running it until we hit the 0th position. And if we also have another block which is very high, we have to stop compared to the current water, the height decay. So if h heights at position is greater or equal to age, we have to stop. We cannot move any further than that, right? And we can actually decrement the position because they're searching to the left. And we need to find out if current age that we know is, we have heights at position is less than age, only know that okay, with the water can move because this current, for example, this is 2, and the index 2, the height is 1, right? And this is lower than that, and we can say our settled position is now at position, and the new height age is going to be, sorry, it's not current age, current height where the water is located, and current height is this is position. And after we're done searching, so current position is indexed as a 2. We'll also modify this variable. Current height is 2, but when you go to the left, this unit of water can find a home because the height is less than the current height, right? So we just say the settled position is this, which is 2, and current height is just 1. And if we can find this one, what do? We actually just go to height and position. We just increment that because there's a 1 unit of water. But what if we did not find a place we could go into the left, And at some point, if settle at is not equal k, in that case, what do you do? If we found that, okay, we couldn't actually find any other place which satisfies this condition, we couldn't find any lower, so we still have the settle at k, right? If that is the case, this is the k, then we need to search for the right. So just like the previous for loop, sorry, I have to just take this out of this one, and once you are done searching for the left side, if you cannot find any place, we just look to the right. And how do you do that? And for position equals k plus 1 at this time, and position is less than n, which is the height, you can actually don't need to create another variable, so I can get rid of that. Highest length, it needs to be less than that, and highest position needs to, if the height at the position is greater or equal to current height. And position is going to be incremented because we are moving to from the k to, we're going to search to the right, and at this point we have to have similar condition if highest valid position is less than current age. What do? We actually do the same thing. So in the position value, if we have some height which is less than our current height, settle age at will be the position, and current age will be at this position, right? So now at this point, we just increment the heights. We get out of the for loop, because and if we cannot find anything else, so whatever the final settle down position is, we just increment that. So I just corrected the variable name, and that's exactly what we need to return, the modified array. So let's run this and see. If I made a typo, there's an S. So there's a small mistake that I need to fix. I will continue searching to the left until the height I'm looking for is as long as it's less than that. So I had this as a wrong sign. It should be less than that, right? So if we just hit that, that is going to be the answer. Yeah. So thanks for watching.